Alright, let's talk relative extrema. So if there's an open interval containing c, which f of c is a maximum, then f of c is called a relative maximum. If there's an open interval containing c, which f of c is a minimum, then f of c is a relative minimum. Basically, a relative extrema exists where the value of the function is larger or smaller than all of the other function values that are relatively close to it. And I just mean basically if we zoomed in really, really close, is it going to be the smallest y value or is it going to be the largest y value? Alright, so example 2, suppose that we're given the function below. We need to label f of a through f of e as absolute or relative extrema. So basically all extrema is relative, but there should be only one absolute maximum or one absolute minimum. Should be actually both. So I know that I'm going to have to label all of these, so I'm just going to go ahead and say I've got f of a, f of b, f of c, f of d, and f of e that I'm going to be labeling. Alright, so f of a, looking at f of a, if I zoomed in really, really close, I see that there's only y values to the right of f of a, and a happens to be the lowest point on that particular bit. So therefore, that is going to be a relative minimum. Alright, but now that I zoom out again and I look at my whole graph, I see that my f of a is actually my lowest y value on that entire graph, which means the f of a isn't just a relative min, it is the absolute minimum. Alright, and then what about f of b then? Well, f of b, now I'm going to go and look at as that tiny little bit. I see, okay, well, f of b is my lowest y value on that little chunk of graph. I see that I've only got y values to the left, and comparatively to what's on the left of that, it is one of my lower points, so that is a relative minimum. And scrolling out, I see that b is not my lowest point, so no, this does not change to an absolute minimum. We've already got one absolute minimum. That's not the most that we can have, but unless it's on the same exact y value the entire time, or it bounces between that lowest y value, I can't really have too many more absolute minimums. Now let's go to f of c. So f of c should be this y value sitting right here. I see that if I zoom in really, really close, I see that the points surrounding it are actually lower y value wise. So that means that I would have a relative max at c. Looking at point D compared to the rest of the graph surrounding it, y value wise, that is the lowest point in that local area. So that does make it a relative min. And then finally on part E, I see that E, compared to the rest of the graph, is a very high point. At least locally, it is the maximum. And then as I zoom out, I see that E is the highest point on that entire graph. So that is actually going to be the absolute maximum. And that's all there is to that one.